Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Alrighty, so today, as you've noticed, we're going to be doing transformations of functions. And understanding what parts of equations do really goes a long way to maybe helping you on the ACT or just understanding graphs in general. So there's some different traits that they all have. So we're going to focus on, I'm going to use what's called a square root function. It's a one-wing function, and I use that because it really does highlight a lot of information. So our goal is to be able to do different things with this particular equation. So I know that if I want to do the math with this, I could do this, and I could try the square root of 0. 0, the square root of 1, 1, the square root of 2. That's irrational. The next nice one is the square root of 4. But I cannot do negatives, non-real answer. Okay, so that's why I happen to like utilizing this basic square root function. So we got a 0 at 0, we got a 1 at 1, 2, and then we'd have to go over to 9 to get the next one, so 5, 6, 7, 8, 9. And it gives us this one-wing function, where the most important part of this is the starting point, which happens to be called a node. You don't have to know the word node, but I thought I'd give it to you. In a previous video, you might have heard me talk about the walls and the ceiling and the floor for talking about domain and range. So what we're looking at here is a domain where x is going from 0, because we included it. We have a wall on the left, and it continues to the right infinitely. We cannot hit infinity, so that's why I use that parenthesis, again from the previous video. We also have range. Range is the ceiling and floor. So those are our y values. And if you notice, we have a floor at 0 and it continues up. So our range is 0 to infinity. So what's going to happen if I adjust the equation? That one I called f, so I'm going to call a new one. I'm going to call it g. What's going to happen if I take g of x and I put a plus 5 in here? Can I do negative numbers now? Yes, I can. Negative 1 was at 2. Now wait a second. Last time I was at 2, I was right here, but now I'm over here. In fact, I'm 1, 2, 3, 4, 5 spaces to the left. That's exactly what this does. It transfers it 5 spaces to the left. So instead of our node being at 0, 0, it's right here. The reason is negative 5 zeroes out the equation. And it's not that x cannot be negative, it's that what is underneath cannot be negative. So that's why we start at negative 5 and we work our way. Everything gets shifted 5 spaces to the left. Okay, so what does that do to our domain? Well, now our walls are at negative 5 to infinity. And as far as our range goes, we didn't move up or down at all, so our range is still 0 to infinity. Okay. What about, let's do an h of x. H of x is going to be the square root of x minus 2. Well, if a plus 5 moved it left 5, then this is probably going to move it right 5. And if you notice, if I put in 0 right now, 0 minus 2 is negative 2. When I try to square that with the calculator is going to throw a fit. The calculator doesn't become happy until positive 2. That's because it shifts everything 2 squares to the right. Okay, so our domain now has the walls at 2 and infinity, and our range still has not changed. So, summary from this part is, if you have a number inside with the x that is being added or subtracted, it will cause a horizontal shift. Okay, and that shift will be whatever makes that 0. So positive 2 makes that one 0, negative 5 makes that one 0. Okay, so that shift will be what zeroes out the parentheses. There are understood parentheses always under radicals. So keep that in mind. Okay, so your shift is going to match whatever zeroes it out, which is kind of like the opposite, right? The opposite of plus 5 is minus 5. Okay, so we investigated what happens if we have a number at the end, or up front in the middle. What if I have a number at the end instead? Okay, so we're going to come back to that same basic graph and let that get focused. Okay, 0, 0, 1, 1, 4, 2. I'm not going to draw all the way to 3, 9. We've got that. That was our f of x, right? By the way, every square root graph is going to have the same basic shape. That's the whole point of this. So this time, we're going to have g of x be the square root of x plus 3. So I can go ahead and substitute 0 in here. The square root of 0 is 0, and then I add 3, I get 3. Wait a second. That went up 3 from the last time. I wonder if I put in 1. Square root of 1 is 1, plus 3 is 4. And if I put in 4, the square root of 4 is 2, plus 3 is 5. It is working. Go figure. So this one moved it up 3. So let's look at our domain and range of that one. Oh, I forgot to write the domain and range of the other one, of the first one down. Again, from earlier, we had the domain 0 to infinity. I've already started shorthanding. I dropped that x as an element of. And our range was also 0 to infinity. Get that x element of, y element of. There we go. Now, our x is still the same, but our y has been shifted. Our floor shifted. We no longer have a bottom floor of 0. We now have a bottom floor of 3. So h of x, and again, these names are just function f, function g, function h. It's just so I can tell which one's which, and so you can tell which one is which. And I'm color coding to help you out as well. So what about minus 4? It will drop it 4 spaces down. And if you guys are familiar with the graph or the program Desmos, Desmos really helps you see these as well. So here our domain is 0 to infinity, but our range is now, we have a floor of negative 4, and it goes up from there. So when we had a number added or subtracted to the end, we had a vertical shift. Up or down. Okay. In summary, we've got A, F, X minus H plus K. So you might have noticed that I did not just write a normal capital H and a normal capital K. I wrote something with arrows, and that's really to help us. Normally we won't see anything in between here, but I'm going to go ahead and put a dot for a times sign. Keep in mind this f of x is that controlling function. Anything on the inside, if it's inside the parentheses, it will cause a horizontal change. Alrighty. Anything outside, will have a vertical change. We just explored what happened with a plus at the end, but we have not explored what happens with a number out front. Okay, so let's just look at that. I'm going to put f of x in orange this time, that way it's a little more subdued. 0, 0, 1, 1, 4, 2. That's our f of x. Again, f of x is that square root function. So what's going to happen if I have 3 square roots of x? Okay. Well, if I put in 0, the square root of 0 is 0 times 3 is still 0. So it's starting at the same spot. If I do 1, the square root of 1 is 1 times 3 is 3. And if I do 4, the square root of 4 is 2. 2 times 3 is 6. So you might notice that it had a vertical change. Why did it have a vertical change? The 3 is on the outside. And it's a stretch factor. Okay, it's a type of dilation. So it's stretched by a scale factor of 3. However, the domain and range are the exact same. Why did I call that F again? Let's call that G. Okay. And then we're going to have H of x. Two-fifths the square root of x. I don't know why I picked 2/5. I guess because it wasn't 1/2. Again, if I substitute 0, I get out 0. If I substitute 1, you can grab a calculator, but the square root of 1 is 1 times 2/5 is 2/5. That's not even half. There's that little bitty dot. And if I substitute 4, the square root of 4 is 2, and 2 times 2/5 is 4/5. Okay, whereas this like stretched it up, this smashed it down, kind of like you smash a pop can. You press it down. So this is compressed by, I'm going to abbreviate scale factor of 2/5. So what's the difference here? Well, if you think about multiplying your bank account by 3, your bank account's going to grow. If you multiply your bank account by 1, nothing's going to happen. But if you multiply it by a fraction smaller than 1, then it's going to shrink or compress. So we can summarize this is if our A value is greater than 1, it will stretch. If the absolute value of our A technically is less than 1, technically it's on both of those. The absolute value, meaning make it positive, distance from 0. If the absolute value is less than 1, but bigger than 0, it will compress. Okay. One thing we haven't talked about is what effect negatives have. So that's our next goal. What do negatives do to this graph? And you're really going to see why I bring the one wing function in now, because things that are symmetric would not show this as nice. So I really like the one wing because it shows the effect of negatives. All right. Bring back our trusted square root of x. And we're going to keep it very, very simple. G of x is going to be So we're supposed to do our square root and then make it negative. Okay? Well, 0 becomes 0. If I put in 1, the square root of 1 is 1, then I make it negative. If I put in 2, the square root of, or sorry, we want to do 4. The square root of 4 is 2, make it negative. It has caused something to happen vertically, but this caused a reflection upside down. Okay. So I wonder what happens if I put a negative on the inside instead. Whoops, h of x. I got busy with my negatives. Okay, well now if I substitute 0, I'm fine. But if I substitute 1, now I have the square root of negative 1, and that doesn't work. But if I utilize negative 1, then I'd have double negatives, which would become positive, and then it works. Notice how that was a horizontal shift? Because it was inside. So this caused a reflection over the y-axis. All right, so let's see if we could take a random picture and do something with it. Okay. Okay, so we have a multiplier. That multiplier causes a stretch. And we have a minus 5 at the end. So if you remember, at the end, when it's outside, that's vertical. Okay, so we're going to be shifting down 5. Now, order of operations says that we stretch first and then we go down. And we have parentheses, exponents, multiply, divide, add, subtract. Why did I write it like that? Because division is a type of multiplication and subtraction is a type of addition. That's why I wrote it like that. Okay, so if you look it up, the absolute value function makes a V. And it normally makes a V right at the origin, going 0, 0, 1, 1, 2, 2, 3, 3, 0, 0, 1, 1, right? Okay. So, what transformations do we need to do? So the first thing we've got to do is we've got to stretch it by 3. So 0 stretched to 0. This went over 1, up 1. So instead of up 1, we're going up 3. And it's symmetrical, so I'm going to go ahead and do that there. And instead of going up 2, we're supposed to go up 6. Okay, so I took care of the stretching. But now we need to move it down 5. Okay, so 0, 0 moved down 5 is right there. Take this point, 1, 2, 3, 4, 5, and this point, 1, 2, 3, 4, 5, and it was symmetrical, so I'm going to use that to help my counting, and we can call it good. All right. So there is going from an equation with a parent function being the absolute value graph and being able to graph it. Even though we really don't know anything about table of values or any of that, we're able to skip all that by taking the initial shape and moving it. All right, this time I'm going to give you a graph, and I'm going to, first of all, tell you the parent function because that's helpful. We're going to utilize the parent function of x squared. Okay. The parent function of x squared, 0, 0, 1, 1, 2 squared is 4. And this is very symmetric as well, but instead of a V, it makes a U. All right. Your goal this time is, instead of me giving you the equation and you making the picture, we're going to start with the picture and you're going to make the equation. Let's call this g of x, just for the fun name. All right, so what effects do we see going on here? Well, if you notice, instead of starting at 0, 0, we've started 1, 2, 3 to the right. So we see a right 3 popping up in there. Also, the vertex has been shifted down 1. So right 3 and down 1 is going to be very important, but now we see that it goes upside down. So it flipped vertically, right? So we have to make sure that we know that we have a vertical flip. Okay. If you remember, negatives are what cause that. So we're looking at our g of x. I don't know why I left that blank. All right. And we have our squared because that's our parent function. The parent function gives us our shape. So inside the parentheses, we need to go right 3. So remember, the 3 is what zeroes it out, so that's why this is going to be a minus 3. Now, the multiplier comes next. That's where our flip is. So it's like having a negative 1 out front. We just write negative. We could write negative 1, not a big deal. So it went 3 to the right, it flipped upside down, and then it dropped down 1. So that's why that goes on the end. Okay. Again, you could also write it, if you preferred, g of x equals negative 1 x minus 3 quantity squared minus 1. So 1 neither stretches it nor compresses it because multiplying by 1, your number just stays the same. So make sure your domain and range are always a positive, that you can do those because you can always be asked those questions at any given time. So just because this one is fun, we're going to go ahead and do the domain and range one more time, just in case you forgot it from previous videos. So even though this looks like it's going straight down, it is still continuing left and it's still continuing right. So our domain on this one is still negative infinity to infinity because there are no walls. Okay, our range, this time we have a ceiling but no floor. So this time our y's start at negative infinity, but they hit that ceiling of negative 1, and there is a dot at negative 1, so make sure you have a bracket there. So domain and range is always a good thing to have. Your vertex will really help you with that. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.